Hi everyone, this is the first problem as exercise for the upcoming quiz we have on Friday, and it's problem 4 in the winter 2016 quiz. The problem is about a tennis ball being dropped from a building with height h. When it reaches the bottom, it has a velocity of v, and the problem is interested with the point at which the ball has picked up a velocity of, speed of v over 2, that being half of the speed that it will get eventually at the end when it drops the whole way. And it asks you for the position and how far is it from the ground. Now, actually, I don't think this is a very easy problem, and I think it's even more difficult to do in an exam setting when you have 50 minutes, you have a lot of other exercises to do. It is easy if you have seen it done before and you know the type of trick that you need to do it. But to derive it mathematically or to really convince yourself that you got it right in a limited amount of time is not easy. So I'm really happy that someone emailed me and requested that I do this problem in a video. Okay, so to solve this problem, we'll first recognize it's a kinematics exercise. And since I'm dealing with velocities and distance travel, you should recognize that this is the equation that I want to use. That the final velocity squared minus initial velocity squared is equal to 2 times the acceleration times the displacement. To make things simpler, I will call the displacement, or I will use the following coordinate, or just simple, that when this thing drops at distance d, then displacement is negative d. And since I know that I started with a velocity of 0, I get the vf squared minus 0 is equal to 2 times the acceleration, which is negative g, times the displacement, which is negative d because it's going down. To get the equation that the velocity squared goes as 2gd. Now, why is this equation important? First of all, it tells you conceptually that the velocity does not go proportional to just d, meaning the velocity is proportional to the square root of d. Meaning that when I travel half the distance of the building, I don't necessarily pick up half of the speed. It's not that simple because they are not related to each other in a linear fashion. So you want to solve this conceptually, just based on the first equation I got there. You can do it the following way. If I were to half the velocity, since that is squared, then I would get only a quarter of the distance traveled if everything else stays constant, which is 2g, which it does. So from that concept, it's telling me that the distance traveled would only be h over 4 as opposed to the whole h. And therefore, my height from the ground would be 3h over 4. So it will be more than half of the distance of the building from the ground. You can also do it if you had solved for VF equals the square root of 2g over d. Same thing. If I want to half this, since I'm here in a square root, then I have to have a fourth to get a 1 over 2 on the other side. If you're not too comfortable with that type of like quick math for concept in your head, we can also solve for this mathematically in a more proper way. And the way you do it is the following. You know that you pick up v squared when the distance traveled is the whole h. And what you're interested in is you have v over 2 when you have some y unknown. Call the first equation 1, the second one 2. From the second equation, I get that v squared over 4 is equal to 2g y unknown. But if I combine it with 1, and I know that v squared equals 2gh, and I get 2gh over 4 is equal to 2g y unknown. You cancel these two, and you get the y unknown is equal to h over 4. All right, so to summarize, we realize it's a kinematics problem. I'm dealing with velocities and displacement, so I want to use this equation. I recognize this is 0. I put my right values for a and for delta y, and I recognize that the velocity square is proportional to 2g times d, or that the velocity goes as the square root of d. Therefore, it's not going to be as simple as half of the distance traveled will give me half of the velocity. Conceptually, you can figure out that if I were to have 1 over 2 in this side, I would get 1 over 4 on the other side. Or you can do the whole math, where you set up the two equations for both situations. One when it traveled the whole distance h, and the other one when it picked up a velocity of v over 2, but you don't know what the y unknown is, and then you solve for the math. And once again, this is problem 4 from winter 2016. As we'll see in the next video, they asked a very similar problem back in winter 2013 and 14. Also, the ball being dropped from the building, but this time asking you about a different variable. Anyway, the point is you should know how to make this problem, how to do this type of problem for Friday. All right, thank you guys, and I hope this was useful.